Hello, everybody. So today we're going to continue our discussion in Chapter 11, Section 3. And if you recall in the last video, we began discussing how to simplify rational expressions. And if you recall what a rational expression is it is an algebraic expression that has a numerator and a denominator. And the way that we simplified those in the second part of the video was that we would take the expressions that we had, and if they were factorable, we factored them, and then we crossed off common factors between the numerator and the denominator. So we are going to continue just trying some problems. We will also write which numbers need to be restricted due to the denominator not being able to equal 0. So let's get started. So you can see in this expression I have a plus 3 divided by a squared plus 5a plus 6. Now what we're going to do first, since we have a quadratic trinomial down here, we are going to attempt to factor that. And if you recall, factoring those, you need two numbers that multiply to give us 6, but will add to give us 5. Now our two factors of 6 would be 1 and 6, or 2 and 3. And the two numbers that will add to give us 5 are going to be 2 and 3. So we can go ahead and break up the denominator into its two linear factors. And those two factors are going to be a plus 2 and then a plus 3. Just like that. Now that we've broken the denominator up, you can see that there is a factor of a plus 3 in the numerator as well as the denominator, so they are both going to cancel, and just like that. And so then what we're left with is a 1 in the numerator, and in the denominator, an a plus 2. Now, we do need to also write what a is not allowed to be. Now, based on writing what a is not allowed to be, you need to look at the unsimplified version. So we actually need to look at these two, and we need to take those two factors before you cross them out and set each of those equal to 0 to solve. And so you can see in this first one, when I subtract 2 from both sides, I end up with a cannot be negative 2. And then the other one, we're going to set a plus 3. We do not want that to be 0. So we'll subtract 3 from both sides. And once again, we'll get a equals, or does not equal, I should say, negative 3. So these two numbers are what we need to restrict our original rational expression to. A is not allowed to be negative 2, and a is not allowed to be negative 3. Okay, so let's try another one. So we have n squared minus 25 on the top, and we have n squared minus 4n minus 5 on the bottom. Now, if you recall, whenever we have ones like this, we want to write them n squared plus 0n minus 25. This will help us make this more factorable, or easier to think about what the factors are. So we need two factors that will add up to be 0, but they will multiply to be negative 25. So going through the factors of 25 here, the factors of 25 are 1 and 25, or 5 and 5. So there's only one way that we can multiply and be a negative and add to be 0. In order to multiply to be negative, one of the pairs of numbers has to be negative. So in this case, it will be negative 5 and positive 5. Because as you can see, if I multiplied those two together, I would get negative 25. But if I added those together, I would get 0. And that's what we need. So this top part, n squared minus 25, will turn into n minus 5 and then n plus 5. Now on the bottom, we have another quadratic trinomial. And same thing, we need them to add to be -4. We need them to multiply to be -5. So the factors of 5 are just 1 and 5. Remember, they need to multiply to be negative, which means one or the other is negative. And they also have to add to be -4. So in order to add to be -4, the 1 actually needs to be positive and the 5 needs to be negative. And so these two right here would multiply to be -5, but would add to be -4. So there are our two numbers. So we will break this one up, n plus 1, and then we have n minus 5, like that. Okay, so we have the numerator and the denominator both broken up. Now, before I'm going to cancel anything out, I actually want to find the restricted values. Remember, the restricted values come from the denominator. So we need to find which numbers would make the denominator 0 and then exclude those. So we just take the factors that are in the bottom and set them equal to 0. So in this case, n plus 1 equals 0. We actually don't want it to be 0. So we'll subtract 1 from both sides, and we get n equals -1. So there's our first restricted value. And our second restricted value, we'll take n minus 5 and set it not equal to 0. We'll add 5 to both sides, and we'll get n equals 5. And there are our two numbers, -1 and +5. Now, the last thing we're going to do is, now that we've found our restricted values, we'll go back up and we will cancel or cross out any like factors that you see. In this case, we have an n minus 5 on the top and the bottom, so we can cancel that out. And what we are left with is n plus 5 on top and n plus 1 on the bottom. And there is our final answer for this one. N plus 5 over n plus 1. Our two restricted values are n cannot be -1 and n cannot be 5. So I have a couple more to show you. They're it's pretty much same as the last ones here. So we have another expression. We have m squared minus 4, and then we have that divided by m squared plus 6m plus 8. So if you look at the m squared minus 4, you can see that if I were to expand this, this would be m squared plus 0m minus 4, like that. Now, we need two numbers that will add to give us 0 and multiply to give us -4. Well, we have two pairs of factors for 4. We can either use 1 and 4 or 2 and 2. Now remember, they need to multiply to be a negative number. They need to multiply to be -4, which means one or the other has to be negative, but they also have to add to be 0. So in order for that to happen, we would have -2 and +2. Those two numbers will multiply to give me -4, and they will add to give me 0. So the next one that we will use is those two to factor that numerator. So the numerator will factor into m minus 2 and then m plus 2, just like that. Now the denominator, we're going to factor it in the same way. We need two numbers that add to be 6 and multiply to be 8. Now if I go through my factors of 8, I have 1 and 8, or 2 and 4. Now we need the pair that will add to give us 6. So in this case, the ones that will add to give us 6 will be 2 and 4. So those will be the two that we use to factor the bottom. So it will be m plus 2, m plus 4, just like that. So now that we have our rational expression fully factored, we want to look at the denominator and determine which values of m we should exclude. So what we do is we just take each of those and set it not equal to 0, like this. So we subtract 2 from both sides, you can see we get m equals -2. Over here, we have m plus 4 can equal 0. So we subtract 4 from both sides. M equals -4. So there are our two excluded values. M is not allowed to be -2. M is also not allowed to be -4. Now from there, we once we find our excluded values, we can go ahead and cancel out any common factors that we see. In this case, we have an m plus 2 on the bottom and the top, so those can cancel, and then we can rewrite our final simplified expression, m minus 2 over m plus 4. There's our final answer. Now, the last one I'm going to show you is very similar to the last three that I did, in that both of these are going to need to be factored. Before we can simplify, we will need to write what the restrictions are on our variable. So let's go ahead and factor the top one. So the top one, they need to add to be 2 and multiply to be 1. Well, there's only one pair of numbers that will multiply to be 1. That's 1 and 1, if we're talking about integers, of course. So 1 and 1 are our numbers. 1 times 1 is 1. 1 plus 1 is 2. So we can go ahead and split this into x plus 1 and x plus 1, just like that. Now that I have the numerator split, the denominator is going to be a little trickier because you can see there's only two terms here. So I do want to expand it out just like I did with the other ones. And I'm going to write in the x terms. This would be x squared plus 0x minus 1. And so that's going to help us now be able to recognize what we need to do to get the correct factors or numbers for our factors. So we need two numbers that add to be 0 and multiply to be -1. So again, there's only one pair of numbers that will multiply to be -1, at least integers anyways, which is -1 and +1. And if we check, -1 plus 1 is 0, they do add up to be 0 as well. So those are going to be the factors. So remember, I rewrote this into this form, just putting the 0x in there so we knew what numbers to use. So once I get the numbers, we know that +1 and -1 are the only two numbers that will multiply to give me -1 and add to be 0. So on this one, we can write x plus 1 and then x minus 1, just like that. Now, we will get our restricted values. Before we simplify, you should get your restricted values. And again, the restricted values come from setting the bottom factors equal to 0. So in this case, x plus 1 equals 0. We actually don't want it to be 0. So by subtracting 1 from both sides, you can see if x is equal to -1, that will make the bottom 0. So we've got to exclude -1. And the second one, we want to set x minus 1 not equal to 0 again. We will add 1 to both sides. X equals +1. So what that means is we cannot have x be 1 or -1 in our expression. Now that we've found our excluded values, we can go ahead and cancel or cross out the factor or factors that we see that our expression has on the top and the bottom. In this case, we have an x plus 1 on the top and the bottom. There's one pair of them, so we can cancel them out, and then we will rewrite what is left, which is x plus 1 on the top and then x minus 1 on the bottom. And there's your final answer. So that's what I have for you today, guys. I hope that made sense. And as always, if you have any questions, feel free to email me. Have a great day.